Hello everyone. I will continue working on the feed-forward neural network function. Then first of all, cost function, then loss function, then gradient learning algorithm, and last one, output unit. First of all, cost function. In a feed-forward neural network, the cost function plays an important role. The categorized data point are little affected by minor adjustment to weight and bias. Thus, a smooth cost function can be used to determine a method of adjusting weight and bias to improve performance. Following is a definition of a mean square error cost function. This is the cost function equation C of W, P equal to 1 by 2n sigma up to x mod of y of x minus a square. Then where W is the weight gathered in the network, P is the biases, N is the number of input for training, A is the output vector, then X means input. Then next, loss function. The loss function is a neural network get used to determine if an adjustment need to be made and learning process. Neurons in an output layer are equal to the number of classes, showing the difference between the predicted and actual probability distribution. Then the following is cross entropy loss of binary classification. The image source as a result of my multi-classes categorization, a cross entropy loss of occurs. Then the equation of loss function, the cross entropy loss L of theta equal to minus log of y cap if y equal to 1, then there is another case minus log 1 minus y cap if y equal to 0. Then next cross entropy loss, another equation like that L of theta equal to minus sigma I equal to 1 up to k yi log y cap I. Then next, gradient learning algorithm. In the gradient descent algorithm, the next point get calculated by calling and gradient at the current position by a learning rate. Then the subtracted from the current position by an achieved value. Then to decrease the function into subtract the value of increased would be added. As an example, here is how to write this procedure. Then the equation of gradient learning algorithm. P of n plus 1 equal to Pn minus eta delta f of Pn. The gradient gets adjustment by a parameter eta, which also determines the step size. Then the performance is significantly affected by the learning rate and machine learning. Then next one, output unit. In the output layer, output unit are those units that provide that describe the output or prediction, thereby fulfilling an task that the neural network needs to complete. There is a close relationship between a choice output unit and cost function. Then next, advantages of feed-forward neural network. First of all, feed-forward neural network offers a simplified architecture that enhance the machine learning capabilities. Multiple neuron network within feed-forward network operate independently with a controlled intermediary. Then complex tasks require a large number of neurons within the network. Then neural networks axial at handling the processing nonlinear data compared to a perceptrons and sigmoid neurons. Then last one, neural networks effectively addresses the indicate challenge of decision boundaries. Uh, there are many applications for these neural networks. First of all, physiological feed-forward system. It is possible to identify feed-forward management in this situation because the central industry regulates the heartbeat exercise. Then uh, gain regulation and feed forward. Detecting non-temporary changes to the atmosphere of a function of this motif as a feed forward system. Then you can find the majority of the pattern in the isolation networks. Then next, automation and machine management. Automation control using feed forward is one of the disciplines and automation. And last one, parallel feed forward compensation with the derivatives. It is an open loop transfer convert a non-minimum part of system into a minimum part system using the technique. And then, uh, thank you.